Hello everyone, welcome to our online class. So in this class we will discuss leftover topic in mean value theorems. Okay. In previous class I explained about mean value theorems of Rolle's theorem definition and how to solve problems on Rolle's theorem. Then we discussed Lagrange's mean value theorem. So definition of Lagrange's mean value theorem and how to solve problems on Lagrange's mean value theorem. And we discussed Cauchy's mean value theorem definition and problems on Cauchy's mean value theorem. Okay, so there is a video mean value theorems. Please go through it if anybody have a doubt and all. Now another two theorems which we have in mean value theorems are what? Taylor's theorem is one is there, and another one is what? Maclaurin's theorem is there. Correct. So let us start with the Taylor's theorem. See the definition of Taylor's theorem. See the definition of Taylor's theorem. If f maps a comma b to R is such that f power n minus 1 is continuous on closed interval a comma b, then second point f power n minus 1 is what? Derivable on a comma open a comma b. Then there exists a point c belongs to a comma b such that f of b is equal to f of a plus b minus a by 1 factorial f dash of a plus b minus a whole square by 2 factorial f double dash of a plus so on plus Rn. So what is Rn here? Remainder ma. So Rn is equal to b minus a whole power p into b minus c whole power n minus p f power n of c by n minus 1 factorial into p. Okay. So this is the statement of Taylor's theorem with a remainder ma. He will ask you this statement for 2 marks. Okay. So luckily I think this time we don't have short answers. Suppose when the short answers available, so this statement will come for 2 marks. Then what is the Taylor series expansion? Then Taylor series expansion can be written as then Taylor series is what? Taylor series expansion about x is equal to a. Taylor series expansion about x is equal to a is defined as, how to define Taylor series expansion ma? About x is equal to a, f of x is equal to f of a, f of x is equal to f of a plus x minus a into f dash of a plus x minus a whole square by 2 factorial f double dash of a plus so on, f double dash of a plus so on. This is the till plus so on till where x minus a whole power n by n factorial f power n of a plus so on, f power n of a plus so on. This is the Taylor series expansion about x is equal to a. This is one we left actually, correct. Next another one is what? We have Maclaurin's, correct. Maclaurin's theorem is there. Let us take the definition of Maclaurin's theorem. See the definition of Maclaurin's theorem. If f maps 0 comma x to R is such that f power n minus 1 is continuous on closed interval 0 comma x. And second point is what? F power n minus 1 is derivable on open 0 comma x. Then there exists a real number small c belongs to 0 comma 1 such that f of x is equal to f of 0 plus x into f dash of 0 plus x square by 2 factorial f double dash of 0 plus so on plus x power n minus 1 by n minus 1 factorial f power n minus 1 of 0 plus remainder. So what is remainder here? Rn is equal to x power n into 1 minus c whole power n minus p f power n of cx by p into n minus 1 factorial. Then what is the Maclaurin series expansion ma? So in Taylor's, in place of a, if you substitute 0, you get Maclaurin series expansion ma. Okay, you get Maclaurin series expansion. What is the series expansion then? Series expansion of Maclaurin's series expansion of Maclaurin's is what? F of x is equal to f of 0 plus x into f dash of 0, same part, plus x square by 2 factorial f double dash of 0 plus x square by 2 factorial f double dash of 0 plus so on. This is the series expansion of Maclaurin's theorem. Okay. Now we'll solve the problems. How the problems is asked? See the first problem. See the first problem. See the first problem. Expand sin x in powers of x minus pi by 4 using Taylor's series. Okay. So see here what he gave here, he wants here, what he wants here, he wants expansion of sin x in powers of x minus pi by 4. So let f of x is equal to sin x ma. Let f of x is equal to what? Sin x, right? Then what is a value he gave here? Here a is equal to what? Pi by 4. In terms of x minus pi by 4 he wants, right? So now calculate f dash of x. F dash of x is what? Sin x differentiation is what? Cos x. Then f double dash of x ma. Cos x differentiation is what? Minus sin x. Then f triple dash of x. This is equal to minus sin x differentiation is what? Cos x. Sin x differentiation is what? Cos x. If you want, you can calculate power 4 also, like so on. F power 4 is what? Cos x differentiation minus sin x minus of minus plus I get. Correct? Now what I need the value of f of a. What I need? I need the value of f of a. Okay. So what is f of x is what? Sin x. Then what is f of a? F of pi by 4 means what? Sin pi by 4. Sin pi by 4. Sin 45 is how much ma? 1 by root 2. Correct. Then what is f dash of a? F dash of pi by 4. Cos pi by 4. Cos 45 is also how much? 1 by root 2. Then f double dash of a, that means f double dash of a value is how much ma? Pi by 4 minus sin pi by 4 is how much? Minus 1 by root 2. Then similarly f triple dash of a, f triple dash of pi by 4 minus cos pi by 4 will give you minus 1 by root 2. Last one, f for 4 of pi by 4 is how much ma? Sin pi by 4 will give you 1 by root 2. So we calculated f dash of x, f double dash, f triple dash. Now what you have to write? You need to write the formula. So therefore, by Taylor series expansion, therefore by Taylor's, what is the formula we have? F of x is equal to f of a plus x minus a into f dash of a plus x minus a whole square by 2 factorial f double dash of a plus so on. Correct ma? This is the expansion of Taylor series. This is the expansion of Taylor series, right? So now what we have to do? You need to substitute the values. What are the values we calculated? Whatever the values we calculated, those all values we substitute here. What is f of x here? F of x is what? Sin x is equal to f of a. What is f of a value? I got 1 by root 2. F of a value how much I got ma? 1 by root 2 plus x minus a. A is what? Pi by 4 into f dash of a. F dash of a how much I got? 1 by root 2 plus x minus a. X minus pi by 4 whole square by 2 factorial f double dash of a. F double dash of a is how much I got ma? Minus 1 by root 2 minus 1 by root 2 plus similarly x minus pi by 4 whole cube by 3 factorial f triple dash. F triple dash also how much I got? Minus 1 by root 2 plus so on. Like this you need to, if you want you can write fourth term also. Like this you need to expand the sin x in powers of x minus pi by 4. In powers of x minus pi by 4. Very very important problem ma. Taylor's and Maclaurin's he will give you one problem pakka. Okay, take down. See the next problem ma. Show that sin x is equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial minus so on. We have sin x expansion formula, correct? In lower classes we used to learn direct formula, but we don't know how it came, right? So using Taylor's or Maclaurin's we can derive this formula ma. How to derive sin x is equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial minus so on. See here. So first to show this one, to prove this one, let f of x is equal to sin x. F of x is equal to sin x. He didn't give any a value, right? So let us take a is equal to 0. Here let a is equal to 0, right? Then what is f dash of x? Sin x differentiation cos x. Then f double dash of x is what? F double dash of x cos x will give you minus sin x. Similarly f triple dash of x is what? Minus sin x differentiation is how much ma? Minus how much it is? Minus cos x. Then f power 4 of x will give you plus sin x. F power 5 of x will give you cos x, right? Then what is f of a here? that means f of 0 here, sin 0 is what? 0, correct? Next, f dash of a, what is f dash of a? A value is 0, f dash of 0 is how much ma? Cos 0. Here you have to write 0, no? Cos 0 is how much? 1. Now f double dash of a, that means minus sin a value is how much ma? 0, will get 0. F triple dash of a, that means f triple dash of a value is how much? 0 minus cos 0. Cos 0 is how much? 1. So minus 1 you get. F power 4 of a, that means sin a, that means a value is sin 0 is how much? 0. F power 5 of x means f power 5 of a, cos a means a value is how much? 0. Cos 0 is how much? 1. Correct? So we calculated these all values. Now what we have to do? You need to substitute these all values. No. So therefore, if you want, you can use Taylor's theorem, or if you want, you can use Maclaurin's also. No problem. So therefore, by which formula? By Maclaurin's, right? By Maclaurin's or Maclaurin's, whatever you call ma. What is the formula? F of x is equal to f of 0 plus x into f dash of 0, x square by 2 factorial, f double dash of 0 plus x cube by 3 factorial, f triple dash of 0 plus so on. Correct? So this is the Maclaurin series formula. Now substitute the values ma. If I substitute the values, what is f of x here? F of x is sin x. F of 0, how much I got? 0 plus x into f dash of 0, how much I got ma? 1, correct? Plus x square by 2 factorial, f double dash of 0, how much I got? 0 plus x cube by 3 factorial, f triple 3 factorial, f triple dash of 0, how much I got? Minus 1 plus x power 4 by 4 factorial, f power 4 is 0 plus x power 5 by 5 factorial, f power 5 of 0 is how much ma? 1 plus so on. Correct? So now if I expand this, what I get here? If I simplify this x, this is 0, I get x cube by 3 factorial, and this part is 0 plus x power 5 by 5 factorial minus so on I'll get. This is the expansion of sin x. Like this, you need to calculate the Maclaurin's, you need to use the Maclaurin's expansion of given function. Understand here? So very important topic ma, and very simple. Only thing is what you need to differentiate the given function and take the a value and substitute, you will get the answer, right? Next problem ma, expand e power x about x is equal to 1. Okay, so what we have to do here, let f of x is equal to e power x, and what is a value? A value is what? 1. Now calculate f dash of x ma, e power x differentiation, e power x only, f double dash of x, e power x only, f triple dash of x, e power x only. Correct? Now f of a means what? F of 1, e power 1 is what? E. F dash of a means that one also e power 1, e only. F double dash of a is what? 1, no, so e power 1. F triple dash of a is also e power a is 1, e power 1. We are getting all are e only. Now by Taylor's, he is asking about x is equal to minus 1, right? X is equal to 1. By Taylor's expansion, what is the formula? F of x is equal to f of a plus x minus a into f dash of a plus x minus a whole square by 2 factorial f double dash of a plus so on. Correct? That is the Taylor series expansion ma. Now substitute here, what is our f of x? F of x is what? E power x. F of a, how much I am getting? E plus x minus 1 into f dash of a, e, x minus 1 whole square by 2 factorial f double dash also e I am getting, right? So take out the e common, so e power x is equal to e into 1 plus x minus 1 plus x minus 1 whole square by 2 factorial plus so on. This is the expansion of e power x about x is equal to 1. Like this you need to solve. Okay. Okay, next very important problem. Verify Lagrange's theorem for f of x is equal to 1 minus x whole power 5 by 2 with the Lagrange's form of remainder, up to 2 terms in the interval 0, 1, right? So what he gave here, here he gave f of x is equal to how much? 1 minus x whole power 5 by 2. Then interval is what ma? 0 comma 1 he gave here. So correct. So what is the first point? F of x and f dash of x are continuous, correct, and f double dash of up to 2 terms is asking, no. So you have to write here up to 2 terms. So what is the first point? F of x comma f dash of x are continuous in closed interval 0 comma 1. Second point, f double dash of x up to 2 terms is derivable, correct, derivable in open 0 comma 1, in open 0 comma 1. Then what we have to prove ma? We have to prove c belongs, then we need to find the value of c that belongs to 0 comma 1, correct. So then there exists a conditions of Taylor theorem. So conditions of Taylor's theorem. So what we are doing here, he is asking up to 2 terms, no. So by Taylor's theorem, by Taylor's, what is the formula we have ma? F of x is equal to f of 0, f of x is equal to f of 0 plus x into f dash of 0 plus x square by 2 factorial f double dash of cx I am taking ma, 2 factorial f double dash of cx with 0 is less than c is less than 1, correct. So therefore, correct, this is the Taylor's theorem with the Lagrange's form of remainder. This is the Taylor's theorem with Lagrange's form of remainder. Now here what is n value? Here n is equal to p, that is equal to 2, and a is equal to 0, x is equal to 1. Here what we took ma? A is equal to 0 and x is equal, if we take here a is equal to 0 and x is equal to 1 and n is equal to p is equal to 2, n is equal to p is equal to 2. Now this, what is f of x here? F of x is 1 minus x whole power 5 by 2. Then what is f dash of x ma? 5 by 2 into 1 minus x whole power 5 by 2 minus 1 is how much? 3 by 2. 5 by 2 minus 1 is how much ma? 3 by 2, correct. Then f double dash of x, what is f double dash of x here? 5 by 2 into 3 by 2, 15 by 4, 1 minus x, 3 by 2 whole power 1 by 2 is how much ma? 1 by 2. 3 minus 2 minus 1 is how much? 1 by 2, right. So now what I need? I need f of 0. So I need f of 0. What is f of 0? 1. I need f dash of 0. F dash of 0 is how much ma? If in place of x if I write 0, 1 minus 0 whole power 3 by 2, 1 power 3 by 2. Next I need f double dash of cx, I need f double dash of cx. That means if I take x is equal to 1, so 15 by 4, 1 minus cx whole power 1 by 2. If I take x is equal to 1, so 15 by 4, 1 minus c whole power 1 by 2. 15 by 4, 1 minus c whole power 1 by 2, correct. And what is f of 1 here? F of 1 is what? 0 here, correct ma? F of 1 is 0. So substitute these all things here. So what is f of x is 1, no? Okay, I'll write here. What is f of 1 here? F of 1 means f of, what is f of 1? F of x is what? 1 minus x, right? So 1 minus 1 whole power 5 by 2, 1 minus 1 is what? 0 we got. So we calculated all the values, right? Now substitute here. If I substitute here, so what I get here? F of x is what? I got 0. F of x, how much I got ma? I got 0. So 0 is equal to f of 0. What is f of 0 value? 1 plus x into f dash of 0. F dash of 0 how much ma? F dash of 0 5 by 2. 5 by 2 or minus 5 by 2? Okay, 1 minute ma, extremely sorry. F dash of x is what? 5 by 2. Again chain rule differentiation of x we have to do, no? So minus 1. Here minus into minus plus. So we'll get here minus 5 by 2. So I'll get here minus 5 by 2 minus 5 by 2 plus plus x square, no? X square by 2 factorial f double dash of x. How much I got? 15 by 4, 1 minus c whole power 1 by 2. Up to 2 terms he says, correct. Now what is x value here? X is how much ma? 1, right? So if I substitute x is equal to 1, if I substitute x is equal to 1, let x is equal to 1. So what I get here? So 1 minus 5 by 2 plus 15 by 8, 1 minus c whole power 1 by 2 is equal to 0, correct. So if I simplify this part, so what I get here, if I simplify this part, see here, okay, just 1 minute. Yeah, if I simplify this part, see here what I get here. So 1 minus 5 by 2 is how much? Minus 3 by 2 will go that side. 15 by 8, 1 minus c whole power 1 by 2 is equal plus 3 by 2. So 2 ones are 2 fours are 1 minus c whole power 1 by 2 will give you 4 by 5, correct? So 1 minus c is equal to 2 by root 5 we get ma. 1 minus, otherwise squaring on, acha, sorry, squaring on both sides. So how much will get here? 16 by 3 ones are 3 fives are 2 ones are 4, right? 16 by 25, right? So this means c is equal to 1 minus 16, 9 by 25. C is equal to how much we are getting? 9 by 25. So approximately 0.36, it belongs to 0 comma 1. It belongs to 0 comma 1. Like this, you need to solve this problem tailored with the Lagrange's remainder. Very important problem. If paper is tough, you are going to get this type of problem. Understand here? Okay. Next, we'll see the next problem. Let's take down this problem. Okay. Next problem, expand log x base e in powers of x minus 1, in powers of x minus 1, right? So how to solve this problem? Solution, let f of x is equal to log x, correct? So what is a value here in terms of x minus 1? No, here a is equal to how much ma? A is equal to 1, correct? Now calculate the differentiation of f of x. So if I differentiate f of x, f dash of x is equal to what? 1 by x. Then f double dash of x, 1 by x differentiation is how much ma? Minus 1 by x square. F triple dash of x minus 2 by x cube. F power 4 of x is how much? Minus into minus plus 6 by x power 4. 6 by x power 4, correct? Minus 1 by x square, and here plus 2 ma, this is minus 6, correct? 1 by x differentiation minus 1 by x square. Minus 1 by x square will give you minus 1 into minus 2 plus 2 by x cube, and this will go to 2 by x cube will give you minus 6 by x power 4. Now f of a, what is f of a value? See here, very simple it is. Only thing is what? 3 to 4 times differentiation. Substitute the a value is nothing but x value. F of a, f of a is what? F of 1 log 1. What is log 1? What is log 1? Log 1 is what? 0. Next, f dash of a means f dash of 1 by 1. How much ma? 1 by 1 is how much? 1. Next, f double dash of a means minus 1 by 1 square minus 1. F triple dash of a, that means 2 by 1 cube. How much? 2. F power 4 of a minus 6 by 1 power 4 will give you minus 6, correct? So these are the things. Now, so therefore by Taylor's, right? So therefore by Taylor's, I am writing directly the thing. F of x is what? Log x base c is equal to f of a. What is f of a? I got 0 plus x minus a. A is what? 1, no? By f dash of a, 1 x minus a whole square by 2 factorial f double dash of a plus x minus a whole cube by 3 factorial f triple dash of a 2 plus x minus 1 whole power 4 by 4 factorial minus 6 plus so on. Like this, you need to expand the given problem about x minus 1 using Taylor's mean value theorem. Understand? So whereas in Maclaurin's, what is the thing you have to take? A is equal to 0 you have to take ma. A is equal to 0 you have to take. Okay. So these are the another 2 topics in mean value theorems which we missed ma. Okay. Practice these all problems and go through these all problems and practice these all problems, and let us see the previous problems also, previous year question paper problems, so that you will become the perfect in this topic ma. Okay. So thank you very much, and please go through that previous video of mean value theorems part 1, and this one will be part 2. Okay. So we'll meet in the next class with a new topic. Okay. Please subscribe to my channel, and please share this video to your friends so that I can make more videos. Okay, thank you.